A prophecy is being sold in Silicon Valley. It is a story of limitless power and infinite intelligence. This prophecy states that a handful of companies, by building ever larger artificial intelligence models, will unlock a technology so profound it cannot be valued in normal terms. OpenAI and Anthropic are the chief evangelists of this new faith. They are sprinting towards initial public offerings, IPOs, on the back of this powerful narrative. Their investors dream of valuations measured not in billions, but in trillions of dollars. This story has captured the imagination of the public, shaping our investments, our career choices, and even how we plan to educate our children. It is a compelling vision of the future, one that promises a revolution unlike any other. Behind this dazzling prophecy, however, a fuse is burning down. While the world is mesmerized by the seemingly magical capabilities of large language models, LLMs, a critical question is being ignored. Is the core assumption of this entire boom actually true? The assumption is that size is everything. It posits that the only path to greater AI capability is through massive scale. More data, more computing power, ever larger models. This idea is the bedrock upon which a mountain of capital has been built. It is the justification for spending billions on specialized computer chips constructing data centers the size of small cities. It is the story that keeps the money flowing. But what if that foundation is cracked? A recent study from the Massachusetts Institute of Technology, MIT, has just dropped a bombshell that strikes at the very heart of this prophecy. The study suggests that the supposed unbridgeable gap between the giant, proprietary models and their smaller, open-source counterparts may be a mirage. It reveals a truth that could unravel the entire narrative of scale as an insurmountable competitive advantage. If the core belief system of the AI boom is flawed, then the rush to go public is not a victory lap. It is a desperate race against time to cash out before the fuse reaches the bomb. The central doctrine of the current AI boom is the gospel of scale. This belief system is championed by leaders like Dario Amodei of Anthropic, who has bet his entire career on a simple, powerful idea. He describes the creation of intelligence as a chemical reaction. The ingredients are data compute the size of the model, combine them in the right proportions, and the output is intelligence. The more ingredients you add, the more intelligence you get. For nearly a decade, this formula has seemed to work. With each new, larger model, skeptics have been proven wrong, and capabilities that once seemed like science fiction became reality. Predictable, scalable intelligence is incredibly attractive to investors. Investors crave predictable growth. If more compute equals smarter AI, the big labs haven't found just a technology. They've found an infinite money glitch. It turns messy scientific research into a manufacturing problem. From that angle, valuations of companies like OpenAI and Anthropic might not just be justified, they might even be cheap. They're buying a stake in a machine that produces the most valuable commodity in history: intelligence. This is the trillion-dollar bet. To make it, companies are spending at a breathtaking rate. The primary cost is compute, meaning tens of thousands of specialized GPUs from companies like NVIDIA. These chips are the shovels in the AI gold rush, and they're incredibly expensive. Then you have to power and cool them in massive data centers. That creates a huge barrier to entry. Only a handful of organizations have the capital and expertise to build these frontier models. That exclusivity is their moat, the defensive wall for future profits. The promise is that massive upfront investment will pay off when models become agentic. They won't just answer questions, they'll execute complex, multi-step real-world tasks on their own. They'll be autonomous agents that can manage projects, write code, run businesses. If that capability only comes at scale, the companies controlling scale will dominate the economy. That's the story they tell investors, employees, and the world. While the gospel of scale is preached in boardrooms and pitch decks, a more complicated reality is emerging from within the labs themselves. The loudest skeptic is Ilya Sutskever, a co-founder of OpenAI. He helped prove bigger models can yield breakthroughs. Yet in late 2025, he declared the age of scaling was over. The easy gains, he argued, were gone. We're back in the age of research. Not brute force, but fundamental unsolved problems. The path forward is no longer a simple matter of adding more compute. Many who work with these tools sense this intuitively. The models are astonishing. They can draft emails, write code, summarize dense documents in seconds. But they also have strange, frustrating limitations. They show a jagged frontier of knowledge. A model might pass a brutal graduate-level exam, then be unable to fix a simple bug in code it just wrote. They can generate a brilliant marketing slogan, then produce the same generic strategy for dozens of companies. Making the model bigger doesn't seem to fix these problems. This phenomenon is called slop. A Harvard Business School study showed this clearly. Leading AI models gave the same fashionable, context-free answers to company strategy prompts. Even with more specific details, the advice barely changed. Models fall back on the most common patterns in their training data instead of reasoning about specifics. Bigger models may just mean a larger, more generic set of patterns to fall back on, making slop worse. This reveals a fundamental misunderstanding. We call it artificial intelligence, but these models do next token prediction. They are gigantic statistical engines calculating the most probable next word from trillions of words. They do not understand or reason like humans. Demis Hassabis says, true AGI will need one or two more breakthroughs on the order of the transformer itself. It's like saying after we invent time travel, teleportation should be straightforward. The easy gains are over. The hard part is just beginning. Yeah. If the gains from scale are diminishing, then the only thing protecting the massive valuations of the big AI labs is their competitive moat. The argument is that even if progress slows, their frontier models are so far ahead that no one can catch up. But, according to a groundbreaking 2025 study from MIT, that moat is looking more like a shallow ditch. The researchers conducted a rigorous comparison between the large, closed proprietary models OpenAI Anthropic and the growing number of open-source models free to download, free to modify, free to run. The results were stunning. Upon release, open-source models typically achieve around 90% of the performance of the closed frontier models on a wide range of benchmark tests. This is already a remarkable finding. The open-source community, through rapid, decentralized collaboration, closes most of the remaining 10% gap within months. A global network of developers constantly fine-tunes, improves, builds upon these models. This rapid catch-up demolishes the idea of a permanent, unassailable lead. Most critically, this is all happening at a tiny fraction of the cost. The MIT study estimated running the closed frontier models costs around 6 times more than running the top-performing open models for only modest performance advantages. The data backs this up. On a benchmark called Humanity's Last Exam, which consists of 2,500 graduate-level questions, a free open-source Chinese model named Kimi scored in the same top tier as GPT-4. Claude 3 outright beating the flagship models from giants like Meta, Amazon. The performance gap is closing, and the cost gap is enormous. This is not just an academic finding. It is already playing out in the corporate world. In June of 2026, Microsoft began moving its main enterprise AI product toward a usage-based pricing model. Microsoft is OpenAI's single largest financial backer. Reports emerged. Microsoft was exploring a free, self-hosted Chinese model called DeepSeek to power some services instead of OpenAI's frontier models. The reason is simple. At enterprise scale, the cost of using the biggest models is just too high. When one of the largest players, heavily invested in the scale is everything story, starts looking for cheaper alternatives, it is a clear signal that the economic moat is rapidly eroding. To understand the risk brewing in the AI market, we need to look back to the year 2000 and a company called Enron. At its peak, Enron was the 7th largest company in America. Its stock had quadrupled in just 2 years. Wall Street had decided it was not a boring old energy company. It was being hailed as a revolutionary technology company. Analysts claimed it was too innovative, too complex, too far ahead. They said it couldn't be valued with normal metrics like revenue or earnings. It was priced on a prophecy of what it could become, not on what it actually was. This should sound eerily familiar. While the world was captivated by Enron's story, a short seller named Jim Chanos did what most people did not. He looked at the numbers. He pulled the financial statements and found a gaping hole. Enron was using an accounting trick, counting possible future money as current income. Chanos did the simple math. For every dollar Enron borrowed to put to work, it got back just 7 cents. But borrowing that dollar cost the company between 7 and 9 cents. The most admired company in America was making no money. We know how that ended. By December 2001, Enron filed the largest bankruptcy in American history. Its stock became worthless. The lesson isn't just about accounting fraud, it's about the danger of believing prophecy over reality. It's what happens when valuation detaches from a business's fundamental economics. Today, Jim Chanos is looking at the AI landscape and says it's worse than anything he's seen. The companies buying expensive AI equipment are not profitable giants like GE or AT&T from the dot-com era. They're mostly other tech companies burning cash. The parallel is stark. Big AI labs have taken on massive debt and huge capital commitments to buy chips that lose value fast. They're betting their technology will produce enough future profit to cover enormous costs. But the MIT study, the rise of open-source models, both suggest their core product, access to a frontier model, may not be a durable, high-margin business. Like Enron, they're being valued on a prophecy. One of the biggest misconceptions about technology bubbles is that they burst because the technology itself fails. This is rarely the case. The internet was a real and transformative technology, but the dot-com bubble burst anyway. Bubbles pop when wealth has to be converted into money. An investor might own shares in a startup valued at $1 billion, but that is just paper wealth, not cash. It is not real money until they can sell those shares for cash. IPOs exist to let early investors and employees finally cash out. Planned IPOs for OpenAI, planned IPOs for Anthropic in 2026 make timing critical. These companies are burning through cash fast to scale. Meanwhile, evidence mounts that their technological moat is thinner than assumed. The moment the market narrative shifts, when the models stop seeming limitless and become another competitive enterprise software category, the premium valuation evaporates. Everyone holding shares realizes the same thing at once. They need to sell before the other guy does. A high-stakes race against time. Founders, venture capitalists rush to convert paper wealth into real money before the prophecy is exposed. They must sell shares to the public, to pension funds, to retail investors, to your 401k, while the limitless story still sells. If IPOs don't happen before the market digests the MIT study or the performance of open-source models, these insiders could be left holding the bag. They'll be stuck running a hugely expensive operation as funding dries up. This is the fatal flaw in the AI bubble. Every time a technology was sold as limitless, limits were later found. Personal computers were supposed to eliminate secretaries. We still have secretaries. ATMs were supposed to end bank tellers. Their numbers grew. Spreadsheets were supposed to kill accounting. Accountants multiplied. The refrain was, "This time it's different." It never was. If the bubble bursts after the IPO, the public will suffer most. The public will be left holding shares based on a prophecy that never came true. Narrator. So, where does this leave us? Narrator. No one can predict the exact date a bubble will pop. Narrator. Jim Chanos didn't predict a date for Enron. He saw the fundamentals. Narrator. He acted on the value, or lack of it. Narrator. We can do the same. Narrator. Don't be swayed by hype or prophecies. Watch for concrete signals. Narrator. There are 3 key questions that will determine the future of this market. Narrator. By focusing on them, we can begin to think clearly for ourselves. Narrator. First, does the scale story hold? Narrator. The bull case rests on bigger models giving step change capability. Narrator. Watch the next generation of models closely. Narrator. GPT-5. Is it a genuine leap? Narrator. Claude 4. Is it a genuine leap? Narrator. Or is it just incrementally better? Narrator. Is it magic or just a more polished version of what we already have? Narrator. If the gains aren't exponential and obvious, the spending and valuations lose justification. Narrator. The story becomes prophecy. Narrator. Second, does the moat hold? Keep an eye on open source models. The MIT study provides a clear benchmark. Do free and open models stay within months of frontier performance at a fraction of the price? Watch what developers and companies actually build on. If they pick cheaper, flexible open models, there's no durable moat. In software, 6 months ahead is no advantage. Third, can businesses support the checks they write? This is the Enron question. Labs took on huge debt to buy chips. Chips can lose value faster than the loans assume. Watch for signs of financial distress. Are profits real and sustainable? Or is survival dependent on continuous new investment? If defaults on massive chip debts begin, that could be the pin that pricks the bubble. Believe the numbers, not the narrative.